enter it in yourself. Those 3 semicolons is the code that you want there for type. And hit enter, and now you can see that the numbers disappear. The formula is still there. It's just hidden. A little bit of a heat map. If you wanted to make it more square, you could kind of close it off like this. However you want. I mean, you can make it, kind of pretty, and then you could cut that out and paste it into a file if you want. But you have a little bit of a heat map there. Now we did this just with the kind of the phyla, the pooled phyla, and you may, that's telling you some changes at the level of phylum, but you may want to look at more specific changes. So if we go to the sheet here, OTU abundance site, what we have here are the OTU identifiers in column A, the taxonomy in column B. And in this case, samples A, samples B, and sample C have been averaged. And instead of being percentages, these numbers are now the total number of sequence reads, or the total number of counts that were averaged in each of those conditions, A, B, and C. You can ignore the statistical metrics over here for a minute. And essentially, we can do the same thing that we did before in terms of looking at the ratio of A to B or B to C or so on and so forth. And so I'm going to look at the ratio of, well, let's just look at the ratio of B to C. Okay. And I'm going to set this up like I did last time. And remember, I'm going to do C divided by B so I can see how does C change relative to B. So that's equals C divided by B. Undo that. Equals C divided by B. Now there's going to be a lot of divided by 0, so it's going to be kind of annoying, but that's fine. And then copy that. And we want to go to the end. Now this is each individual OTU that were in the sample, so there's tons of these. So you go all the way down to the bottom. I think there's like 22,000 or 19,000. And we can go paste. So that's showing us how the values changed. And then we can select everything. And go to data, sort. Now this has headers. We want to sort on B to C ratio, largest to smallest. And of course all these division by zeros you can ignore, and we can start to see which groups had the most significant change in C relative to B. So all these numbers that are above 1 means that there was a huge increase in C, and all the numbers that are below 1 means that they're decreased. Okay, so if it's 96, it's essentially 100 times more common in C. So it's 100 times more enriched in C than it was in B. And then if you go down to the bottom, then these small values, and then you get to 0, almost 100-fold decrease in these ones that are, say, 0.01. Of course, now we can go up, and we can look to see what are these that change so dramatically. So there's a firmicutes, proteobacteria, more firmicutes, more proteobacteria. That's similar to what we saw when we looked at the level of phylum. Now, one of the things that you might want to do is to say, okay, if you wanted to look at the sequence of which bacteria was actually accounting for that, then you can take the OTU identifier here, and you can look over in the OTU rep sequences. And you want OTU 714, so let's see if we can find that. Search. Okay, here it is. New cleanup reference OTU 714. Here is a sequence for that. So we can go up here and select the sequence, Control copy, nucleotide blast, paste in your sequence. Select on this pull-down menu to 16S, and you can limit the sequence from type material. That sometimes reduces the number of hits you get back. And then hit blast. And again, depending on how heavily the server is being used, your results can be back really quickly, or it can take a couple minutes or more. And here we go. So here's our blast hits. And our best match is something I've never heard of before in the Bacillus genus. Pretty high identity. E-value score means that there's almost no chance that that sequence would randomly match to the one that's in the database. So that's good. But you can see that there's a bunch of them that have a 0 e-value. So that means, and that's why the identification didn't go all the way down to genus, is because there are many hits that have almost the same quality of match. And so you can't, with the information that you have in the sequence, you can't tell the difference between if it's Bacillus safensis or Bacillus niancini or what have you. So, but you can be pretty comfortable that it's Bacillus. And if you click on that, then you can go to the alignment, and you can see that there are some gaps, and everywhere where there's not a line connecting them, the sequence, there's some mismatch. So it's not perfect. There's a lot of mismatches in this area, but it's pretty close to this strain here, or at least that's the closest, one of the closest matches. And then if you're interested, you can look up to see exactly what this is. Maybe, see if there's any information there, so we can kind of Google that. Strain JCE was isolated from a fecal sample of a 20-year-old obese man living in Jeddah, Saudi Arabia. So you get information on what it's closely related to. So that's how you can kind of search around and find more information.